Hello, fourth grade, and welcome back to science. We are beginning module 5, so 1, 2, 3, 4, 5, and our module is going to be titled Patterns of Earth's Changing Features. Now we're going to begin with lesson 1, and our lesson 1 is titled Earth's Landforms and Features. Let's go ahead and watch our short little video here, and then we'll jump into our work.
Hi, my name is Maya. Take a look at what I found while hiking. To most people, this is just a rock, but I want to know so much more about it. How did it form? What is it made of? What type of rock is it? How old is it? When I grow up, I want to be a geologist. Then I can study rocks all the time. Geologists spend a lot of time outdoors. Prepare to get dirty. Geologists do a lot of digging. You never know what you'll find when you are a geologist. I have even found rocks with fossils. This one's going right in my rock collection. I don't think I have this one yet. Happy digging!
All right, let's go ahead and start our lesson. Now, the first thing we're going to do is, of course, answer our first page. And this is titled Land and Water Features. So we're going to go ahead and read through the scenario here. You're going to decide which one of the friends you agree with the most, and you're going to explain your reasoning. So I agree with this person because, give reasons to defend your answer. Once you've completed that, we're going to jump into our next page, and we're going to look at the aerial photo of Mount Everest. You're going to write down what questions you have about the image. So here's our picture of Mount Everest, and an aerial photo is just a picture or photo that's taken in the air, so off of a plane or a helicopter. Write down whatever questions you have for that. And then you're going to read about the cartographer. Now, it's a short read over here, and then you just have these two questions. What do you think the cartographer does based on the field notes? And what do you think a geographic information system is? Once you've used complete sentences to answer both, you're going to try out your essential question as best as you can. What are Earth's features? So remember, when you are answering your questions, please use complete sentences. So for this question, it says, what do you think the cartographer does based on the field notes? Your answer can say, based on the field notes, I think a cartographer, and you're going to tell me what you think they do. For the second question, what do you think a geographic information system is? You can say, I think a geographic information system is, and then you can tell me what you think. All right, moving on. We're going to take a look at our vocabulary. So our vocabulary words for this lesson are the words landform, continent, plate tectonics, volcano, earthquake, fault, and topographical map. We are going to watch our video on landforms and the features that cover the Earth's surface, and then we're going to answer our questions. What type of landforms did you see in the video? What types of landforms have you seen? And then we're going to jump into our textbook after that. Let's go ahead and pull up our video. Actually, let's review our vocabulary together first, and then we'll go to the video. So the word landform is a physical feature on Earth's surface, like a mountain or a river or a lake or a canyon. All of these are different landforms. A continent is a large landmass, so it's a large area of land. Plate tectonics are a scientific theory that the Earth's crust is made up of moving plates. So think like puzzle pieces. The Earth's crust is made up of parts that line up with each other or that will rub against each other. A volcano is a mountain that builds up around an opening in Earth's crust. An earthquake is a sudden shaking of the rock that makes up Earth's crust. So when you're feeling the ground shake. A fault is a break or a crack in the rocks of Earth's crust where the movement can take place. And a topographical map is a map that shows the elevation of an area of Earth's surface using contour lines. So a topographical map shows elevation. That means the height of different parts of the Earth, and it uses lines. So when the lines are spread apart, they mean one thing. When the lines are really close together, they mean something else. And we'll get into details about that as we move on. Let's go ahead and watch our video.
Earth's surface is covered in landforms. Let's take a look at some of them. The first landform we're going to look at is located in the eastern part of the United States. Mountains. Next, we're going to travel all the way to Russia to view a volcano. We'll fly to Australia to see our next landform, plains. Now, we'll go to the southwestern United States to see a plateau. The next landform we'll see is in Argentina, a valley. Now a quick flight back to the southwestern United States to see a canyon. The last landform we'll look at today is located all the way over in the Middle East, sand dunes. What types of landforms have you seen before?
All right, so let's go ahead and head back into our work. And you're going to answer your question, what kind of landforms did you see in the video? So you'll say, in the video I saw, and then you can list some of the landforms. And then for the second question, what type of landforms have you seen? Tell me about ones that you've seen in real life. Okay, now that you've finished answering those two questions, we're going to jump into our textbooks on page 141 to 143, and we're going to answer the questions, what is a landform? What is a valley? What is a plateau? What is a desert? And what is a tributary? So when you answer your questions, again, complete sentence, a landform is, a valley is, a plateau is, and so on. Earth's layers. The geosphere includes both Earth's surface features and its interior. Scientists divide Earth into several layers. The crust. The crust is the rocky outermost layer of Earth's surface. It varies in thickness from 6 kilometers, which is 4 miles, to 70 kilometers, which is 40 miles. The crust includes the continents and the ocean floor. All of Earth's land and water features are found here. The crust is brittle and can crack easily. The mantle. The mantle is a layer of Earth's interior below the crust. It's about 2,900 kilometers thick. It's divided into the upper and lower mantle. The top of the upper mantle is solid rock. Together, the crust and the top of the upper mantle form the lithosphere. The rest of the upper mantle is almost melted rock. This part of the upper mantle is called the asthenosphere. The rock here is under great pressure. It can flow slowly like thick putty. The lower mantle is solid rock. The core. The innermost layer of the Earth is the core. The outer core is a liquid layer that is made mostly of melted iron. It's about 2,300 kilometers or 1,400 miles thick. The inner core is a ball of solid material at Earth's center. This is the hottest spot on Earth. Evidence suggests that the inner core is made up mostly of iron. Intense pressure from the weight of the surrounding layers makes the inner core solid. It's about 2,400 kilometers or 1,500 miles in diameter. All right, let's go into the landform section, which is going to be the part that answers your questions. A landform is a physical feature on Earth's surface. Landforms vary greatly in shape and size. They include features such as level plains, rounded hills, and jagged mountains. Landforms of the continental United States. If you were to travel across the continental United States, you would observe a variety of landforms: mountains, plains, canyons, and sand dunes. Landforms. Type of landforms. From outer space, Earth's land might seem flat. On Earth, you can see many landforms on its surface. Each landform has specific characteristics, and each forms in a different way. Use the labels on the image below and the descriptions on the next page to learn more about common landforms. Mountains. A mountain rises high above the ground. So these are our mountains. A hill is lower and rounder than a mountain. So these are hills. You can see they're not as tall, they're not as jagged. A valley is the lowland between hills and mountains. So you can see where it dips over here between hills or mountains. That's a valley. Canyon. A canyon is a deep valley with high, steep sides. So here you can see a canyon. It has very high, steep sides and it dips straight down. Cliff. A cliff is a high, steep section of rock or soil. So let's go ahead and take a look over here. This is a cliff. It's the very edge of land before there's a drop. Plain. A plain is a wide, flat area. So if you're looking at plains, let's see where they have plains listed on your diagram. So plains over here are just wide, flat areas. A lot of these areas are used for things like farming. A plateau. A plateau is flat land that is higher than the land around it. So a plateau is a raised up flat area of land. When we're looking at our plateau, you can see over here, this is the regular land level. This plateau is kind of raised up, but it's still flat. So it's almost like a flat hill. Next, we have the desert. A desert is an area with very little precipitation, so very little rainfall. That's where you find your desert. So it's usually dryish, more brownish colored because there's less plant life there. A beach is the land along the edge of a body of water. So your beach is going to be right here. So right at the edge of the water, that's your beach. A dune is a mound or ridge of sand. So a dune are like little hills made up of sand. Earth's water features. An ocean is a large body of salt water. So here's your ocean. A coast is where the body of water meets the land. So the place where the water touches the land part is called the coast. A tributary is a small river or stream. So tributaries are pretty tiny, just like these little guys over here. It's a small river or stream. A river is a natural body of moving water. So rivers are a lot wider. They usually connect to a larger body of water. A waterfall is a natural stream of water that's falling from a high place. So over here, you can see a waterfall. It's dropping down. It's feeding into those tributaries. It goes into the river that goes out to the main body of water. A lake is a body of water that's surrounded by land. So it doesn't empty out into like an ocean or a lake. An ocean or a river. It's kind of enclosed. It's got land all the way around it. An estuary is where the river water and the ocean water meet. So over here, where a river connects to the ocean, we call this section the estuary. And a delta, which is also down here, is the mass of land that forms at the mouth of a river. So the land over here at the mouth of a river is called a delta. The inlet is a narrow body of water off of a larger body of water. So an inlet is like this little section over here. So our main large body of water is out here. This little section that's connected to it is called an inlet. So we can go ahead and answer our questions over here. Next, we're going to read pages 144 to 145, and we're going to answer our next set of questions. How are the continental shelf and continental slope related? What connects the continent with the ocean floor? What are mid-ocean ridges? Which ocean floor feature is flat? How do scientists observe the ocean floor? How are features found on the ocean floor similar to features found on land? So we've got a lot of questions that we're going to answer over here. Let's go ahead and get back to our book. We're going to jump to pages 144 to 145. Okay, Earth's ocean features. Oceans are large bodies of salt water. Earth has 5 oceans, which are all connected. Together, they cover more than 70% of the Earth's surface. Ocean water plays an important role in the water cycle and contains nutrients that support a variety of living things in the biosphere. Ocean floor. Although waves move over the surface of the ocean is mostly flat. However, if you could travel deep below the ocean's surface, you would find features on the ocean floor that look like mountains, plains, and valleys. An ocean basin is a large underwater area between continents. Along the coast of a continent, the ocean floor is called the continental shelf. So right over here is the continental shelf. Here, the ocean floor is covered by shallow water that gradually slopes down. The continental shelf can stretch seaward for miles. A continental shelf ends at the point where a sharp downward slope begins. This sharp slope is called the continental slope. So over here, you see where it drops suddenly. That's the continental slope. This land is the steeper part of the continent that slopes down towards the ocean floor. Underwater canyons can form on the continental slope. Did you know at 11,034 meters deep, or 36,201 feet deep, the Marianas Trench is the deepest part of the ocean? At the base of the continental slope is the continental rise. The continental rise connects the continent with the ocean floor. Pay attention because these are answers to some of your questions that we read so far. Most of the ocean floor is flat and without features. These wide flat areas are called abyssal plains. They cover about 40% of the ocean's depths. So abyssal plains are large, just flat areas. Here's our continental rise that connects. Other ocean floor features include trenches and seamounts. Trenches are the deepest part of the ocean floor. So over here. A seamount is an underwater mountain that rises from the ocean floor but stops before it reaches the surface of the ocean. So this is a seamount. So it comes close, but it never actually gets to the surface of the ocean, so you can't see it from the top of the water. Scientists use underwater vehicles to observe the ocean floor. These vehicles may carry cameras, instruments to measure the underwater environment, or mechanical arms to gather samples. Scientists also measure the depth of the ocean floor. They send sound into the ocean and wait for the echo to come back. Oceanographer. Interested in exploring the depths of the ocean? Oceanographers apply their knowledge of chemistry, biology, geology, engineering, and math to answer questions about the processes of the ocean. Learn more about a career in oceanography in the careers section. This coral reef formed at the shallow continental shelf. So over here we have the edge of the continent. The continental shelf is where it connects to the water. The continental slope is where it takes a sharp downturn. It drops and gets very, very deep. The continental rise connects the continent with the ocean floor. And then we have the seamounts, which are underwater mountains, the abyssal plains, which are like the plains that we have on land. We have mid-ocean ridges that are just these really deep areas. The deepest part are the trenches. So we can go back now and answer our questions. How are the continental shelf and continental slope related? We can say the continental shelf and continental slope are related because, or they're related by, an answer. What connects the continent with the ocean floor? You can tell me the answer there. What are mid-ocean ridges? Which ocean floor feature is flat? How do scientists observe the ocean floor? How are features found on the ocean floor similar to features found on land? So all of this we just went over in our reading and our discussion. Please make sure you use complete sentences and really neat handwriting to complete those questions. Next, we're going to read a handout entitled How Earthquakes and Volcanoes Shape the Earth. So the questions we're going to answer are what happened 250 million years ago? How do colliding plates form a volcano? And what is a fault? So let's go ahead and open up our handout. How earthquakes and volcanoes shape Earth. Shaking things up. Rumble, an earthquake shakes the ground. Crash, a tree falls down. Whoosh, a volcano explodes. Lava pours out. Lava is red-hot liquid rock. It destroys everything in its path. Volcanoes and earthquakes are natural hazards. A natural hazard is caused by a force in nature. It can harm people. A hurricane is a natural hazard. A tornado is a natural hazard too. What if people could stop all natural hazards from happening? Would that be a good thing? It might not be. Earthquakes and volcanoes can cause harm, yet they can be helpful too. Earthquakes and volcanoes have helped to shape the Earth. When Earth was a young planet, there was no atmosphere. For millions of years, volcanoes erupted. Gases from the inside poured out. Those gases became part of the atmosphere. With time, some formed rain that fell and became the first ocean. Our puzzle planet. Earth has an outer layer of solid rock called the crust. The mantle is the layer beneath the crust. The crust and the upper mantle are broken into very large pieces. The pieces are called tectonic plates. They fit together like pieces of a jigsaw puzzle. The plates move over a layer of hot, almost melted rock that can flow. Earth's continents cover some of these plates. The ocean covers other parts of the plates. So here you can see the tectonic plates, and the gray parts, the outlines are the plate boundaries. The plates creep along very slowly. Usually you cannot tell they're moving. Picture a lake filled with big floating rafts. Some rafts bump into each other. Other rafts float apart. Others slide past each other. Earth's plates move like the rafts. They move together, apart, and past each other too. The place where two plates meet is a plate boundary. Many earthquakes happen near plate boundaries too. Volcanoes. Two tectonic plates can come together at plate boundaries. One may slide under the other and sink into the hot mantle. Some of the sinking plate melts. The melted rock rises up through the cracks in the rock above. Sometimes an opening forms in the rock at the surface. Then burning hot lava bursts out of the ground. A volcano forms. When a volcano erupts, rock, ash, and hot gases come flying out with the lava. An eruption volcano can destroy everything around it. Another look. In some places, people use water heated by melted rock inside the earth to make electricity. That's helpful to people. Yet melted rock in the form of lava can cause much harm when a volcano erupts. Lava, rock, ash, and gas can erupt from a volcano and cause harm. Almost 2,000 years ago, there was a town in Italy called Pompeii. It was near a beautiful mountain called Mount Vesuvius. The mountain was really a volcano. It had not erupted for hundreds of years. Suddenly, the quiet mountain blew its top. People tried to run away. Rock and ash buried the town and many people. Pompeii is an example of how volcanoes can cause harm. The city of Pompeii was destroyed when Mount Vesuvius erupted. Volcanoes can destroy. They can also build up Earth's surface. After lava erupts onto a surface, it cools and hardens into new rock. This happens again and again. Each time a new layer of rock forms. This rock builds up Earth's surface. The rock layers slowly build up to form mountains. This happens on continents and under the ocean. When enough underwater rock builds up to rise above the ocean surface, an island forms. The island of Hawaii formed this way. Erupting volcanoes send out ash too. This ash can harm living things as it falls and covers the ground. It can also help by adding minerals to the soil. Minerals are nutrients that living things need. When ash mixes with soil, it makes the soil better for growing plants. Earthquakes. One spring day in 1960, the ground began to shake in the town of Valdivia, Chile. People rushed out of their houses. A large earthquake had hit. Almost all the buildings were knocked down. It was the biggest earthquake ever recorded. And here you can see what some of the buildings and houses look like. Like volcanoes, most earthquakes occur because of moving tectonic plates. Cracks called faults from the Earth's crust. Cracks called faults form in Earth's crust as the plates move and change. The rocks on either side of the fault can move. When these rocks move suddenly, an earthquake happens. The crust shakes with a little or a lot of energy. The energy spreads out as waves through the earth. If the waves are weak, people might feel the ground shake a little bit. If the waves are strong, houses, cars, and even boats in the ocean can be tossed around. Buildings and roads can be damaged or destroyed. Earthquakes can destroy, yet movement along faults can build up Earth's surface. Land gets pushed up when two plates push together. Faults form. Rocks on one side of the fault get pushed up over rocks on the other side. This can form mountains. Part of the Rocky Mountains form this way. All right, so after going through all of that information, we can go ahead and answer all of these questions. If you're not sure about anything, please do go back to the handout, read through everything very carefully. There is a lot of information here. And then you can go ahead and use complete sentences to make sure you answer the questions. All right, moving on, we're going to investigate how the locations of the tectonic plates are related to the locations of volcanoes and earthquakes by conducting a simulation. And then we're going to answer these questions. What do you observe about the plate boundaries? Look at the arrows. How do you think earthquakes happen when plates move? And then we'll jump back into our handbook after. Earth's crust is made up of large pieces called tectonic plates. There are 15 of these tectonic plates. The movement of these plates can cause earthquakes and volcanoes. This movement is sudden and can result in huge destruction. These disasters cannot be prevented. However, humans can take steps to lessen the damage. Select an area on the map and see the plate lines on it. See the plate it lies on. Observe how plates can move in different directions. Identify patterns in the location of earthquakes and volcanoes. So if we click on this particular plate, the yellow dots show minor earthquakes. The orange dots show medium earthquakes. The darker orange dots show major earthquakes, or the red dots, and then the purple dots show volcanoes. So you can see that there are volcanoes that kind of form around the edge of this plate or the edge of this continent. Let's take a look at this one. Over here, major earthquakes and lots of volcanoes along the edge of this tectonic plate. And you can see this plate kind of runs all the way around. If we click another one, again, lots of earthquakes, lots of volcanoes all along this edge. And you can see kind of along all of the edges of these plates, that's where you're going to find a lot of this activity. So some famous earthquakes and volcanoes are highlighted on this map. Select each to learn more. So we can click on this one. Mount Pelée. There was a large volcano that erupted in 1902. If we go over here to Mount St. Helens, this is located Up in Washington, this was a very large volcano that erupted in 1980. Over in Anchorage, Alaska, there was a big earthquake that measured a magnitude of 9.2, one of the biggest earthquakes. If we go out here to Tangshan in China, again, another very large earthquake in the year 1976, measured a 7.5 magnitude. An earthquake in Japan measured 9, and this was in 2011. We can move down to Sumatra, Indonesia, and there was a magnitude 9.1 earthquake in 2004. And in the Philippines, there was a colossal explosion from a volcano in 1991. All right, what did you observe about plate boundaries? Look at the arrows. Why do you think earthquakes happen when plates move? So again, you can see where some of these arrows are, and you can see which way the plates are moving. Once you've completed that, we're going to jump back into our textbook and we're going to read pages 418 and answer the question, why do people use maps? What type of information might be featured on a map? And what does a relief map show? All right, so page 418. How scientists use maps. Many scientists depend on maps. They use maps to organize and analyze information. They also use maps to share information with others. Maps help scientists to understand organisms and ecosystems. For example, scientists studying lizards in Madagascar make maps to show where the organisms are located. The maps also help them compare where they predict lizards are likely to live and where they actually observe them. Their maps help them find patterns in their data and understand what animals need to survive. Scientists use maps to show where different kinds of landforms, soils, and rocks are found. Analyzing and sharing these maps helps scientists better understand Earth's features and how they change. This is a map of Madagascar. It helps scientists understand lizards and their ecosystems. So these little circles show where the lizards were observed. The yellow area is where they expected to find them. And the green section right here, the picture of the green lizards, shows new observations where they found them for the first time where they didn't find them before. This relief map uses shading to represent different elevations of major landforms. You can use it to find out where most mountains are found in the continental United States. So again, we're going to head back. Why do people use maps? What type of information might be featured on a map, or what might you find on a map? And what does a relief map show? Then we're going to take a look at our digital interactive patterns on Earth's surface and answer question number 22. What do you notice about the location of earthquakes and volcanoes?
Click on the slides to learn the location of Earth's varied landforms. Mountains are the highest landforms on the planet's surface. Mountains are often cone-shaped, with steep sides and pointed peaks. A series of connected mountains is called a mountain range. Mountain ranges can form when parts of Earth's surface moves horizontally, pushing the land upward. Some mountain ranges are the result of volcanic eruptions and the buildup of lava rock. Mountain chains are found on every continent. An earthquake is a sudden shaking of Earth's crust. It is caused by sudden movement along a fault. When forces push and pull a plate, energy builds up. Earth's crust may store this energy for many years. Then suddenly, the energy is released. The rock breaks apart and moves along the fault. Earthquakes are common in places with active faults, like parts of Alaska and California. Volcanic activity can bring out melted rock, gases, ash, and rocks from deep within the earth to the surface. By erupting often, a volcano can build a large mountain out of layers of cooled lava and ash. Most volcanoes occur at the edges of plates. When two plates meet, one can sink below the other. As it sinks, the plate gets hotter. The rock melts into magma. The magma rises and forms a volcano. Volcanoes also form where Earth's plates move apart. Hotspots are places where Earth's crust is very thin. Magma can easily break through to the surface. The islands of Hawaii formed over a hotspot in the Pacific Ocean. The islands are the tops of huge volcanoes that rose from the ocean floor. Earth has an outer layer of solid rock called the crust. The mantle is the layer beneath the crust. The crust and the upper mantle are broken into very large pieces. The pieces are called tectonic plates. They fit together like pieces of a jigsaw puzzle. The plates move over a layer of hot, almost melted rock that can flow. Earth's continents cover some parts of these plates. The ocean cover other parts of plates. The plates creep along very slowly. Usually you cannot tell they are moving. They move together, apart, and past each other. The place where two plates meet is a plate boundary. Look at the different symbols for mountains, volcanoes, and earthquakes. See how, in many areas, these features are in the same place or very near each other? Mountain ranges, volcanoes, and earthquakes all occur near plate boundaries.
All right, let's go ahead and jump back into our book. What do you notice about the location of earthquakes and volcanoes? So we saw multiple slides. All of them kind of showed us the same thing. So the edges of these plates are where you're seeing a lot of earthquakes and volcanoes happening. And the reason that's happening is because these tectonic plates are shifting, because they're creating cracks and they're pushing up parts of land. That's what's leading to the earthquakes. That's also what's leading to the formation of these different volcanoes. All right, once we've completed that, we're going to jump into our next pages. Read the third paragraph on page 415 in your science handbook. Answer the following questions after you finished reading. How are the contour lines arranged in an area with a very gradual slope? How are the contour lines arranged in an area with a very steep slope? So gradual means it moves up or down just very slowly. Gradual means slow. Steep means it's a very sharp drop. How would these lines be arranged on a topographical map to show where a mountain was located? So we've got our three questions here, and we're going to read our third paragraph over on page 415. So this paragraph down here. It says a topographical map uses lines to show elevation. Each line represents a different elevation labeled with a number. In addition to elevation, contour lines can tell you how steep or gradual a slope is. Contour lines that are close together represent a rapid change in elevation, so it's changing very quickly. Contour lines that are far apart represent a gradual change in elevation, or a height difference or elevation difference is changing very slowly. So how are contour lines arranged in an area with a very gradual slope? How are they arranged in an area with a very steep slope? And how would the lines be arranged on a topographical map if we were showing a place where a mountain is located? So again, think about this information. Read through it very carefully one more time, and then go ahead and answer your questions. Once you've completed page 219, we're going to jump into our final pages over here for our lesson. Landforms from another planet. This is our performance task. So we're going to use modeling clay, pencil, ruler, some dental floss, and some graph paper. Suppose that a distant planet has just been discovered. The planet is very similar to Earth. Information gathered by deep space telescopes shows that the planet contains several common landforms that are found on Earth. Data have also shown that this newly discovered planet has oceans of water, mountain ranges, volcanoes, ocean trenches, and ocean ridges. You will create a topographical map of a landform found on the planet. What question will people on Earth be able to answer about the landform using your topographical map? So after they look at the map that you're making, what will they know? What question can they answer? So you're going to choose one of the landforms that's found on this newly discovered planet, and you're going to make a model of it using clay. Using the pencil, poke a hole through the center of your landform. Measure the height of your landform in centimeters. Use a dental floss. Cut a slice 1 millimeter in thickness off of the top of the landform. Place that slice of landform onto a piece of graph paper. Trace the edges of the slice and mark the location of the hole in the middle. Then put the slice to the side. Cut the next 1 centimeter slice of the landform and place it on the graph paper so that the hole in the middle of the slice still lines up with the spot that you marked, and then trace the edges of that slice. Line up and trace the slices for the rest of the landform. When you're finished, put the clay landform back together. Switch maps with a classmate and don't show your classmate the model landform that you created. Have your classmate use your map to try and recreate the model landform using clay. Explain how you use the topographical map to create your classmate's model landform. Compare the original model landform to the one that you created with your classmate's map. How close were they to the original landform? And then number 3, what would you be likely to find? Where would you be likely to find the landform that you mapped on the distant planet? Place an X on the map of the planet below. Use what you know about patterns in the location of Earth's features to form an explanation about where the landform is likely located. So the landform that you created, where would it be on your planet? So put an X somewhere on there and explain why it would be found there. And then your essential question, think about the photo of Mount Everest that you saw at the beginning of the lesson. What do you know about where mountains are located? Use complete sentences and lots of details, and you don't need to complete the I did statement. That takes us to the end of this lesson. If you have any questions, let me know. Otherwise, I hope you guys have a wonderful day. Take care. Bye-bye.